Hi everyone, in this video we are going to analyze the graph of a hyperbola, identify key parts like the center, vertices, and foci, and use that information to help us to graph hyperbolas and write their equations. So let's dive right in. So when we have a hyperbola, there are two ways that the hyperbola can open, so either in the horizontal direction or the vertical direction. You have two equations, and they are very similar to the ellipses. The one thing you need to remember is that in your equations for hyperbolas, the a is always first. Now, in an ellipse, it was different based on which one had your major axis. Just make sure you remember that the A is always first. And then the other thing that does change is the X and the Y. So wherever you see the A, you're going to look at the X or the Y, and that's going to tell you whether your hyperbola is going to open in the horizontal versus the vertical direction. You also have a transverse axis, and you can think about that as the segment that is joining the vertices. And that's also very similar for you to know is the same thing as your major axis. You have some sketches here, and we'll talk about why the box and the sort of dotted X is important when you are drawing your hyperbola. Some things just for you to remember as well as A is the distance from your center to the vertices. C is the distance from the center to the foci, so that's very similar to what you had in the ellipse. To find your foci, you're going to use, again, a very similar equation. However, it is c squared equals a squared plus b squared. Okay, so the first thing you want to do is you want to find the center. So you have your x here, which is -2, and you have your y, which is 3. So you have -2 and 3 as your center. Now the next thing we're going to do is find the vertices. Now because the a squared is always first, the way that you know which direction your hyperbola will open is the fact that x is here in the first fraction. So this will be a hyperbola that opens in the horizontal direction. So you have a squared is equal to 9. So when you solve, a is plus or minus 3. Now, keep in mind you are going to go plus or minus 3 along the x because that's the part of fraction that you have. So we're going to the right, 3, and to the left, 3. So the coordinates for those vertices are -5, 3, and 1, 3. So those vertices are going to be important when you are looking at drawing your hyperbola. Now, you have b squared here, so b squared is 16, so b is plus or minus 4. Now you are on the y, so you're going to go plus or minus 4 in the y direction, so up or down. So 1, 2, 3, 4. 1, 2, 3, 4. So now what you can do with this information is you can draw your box. Now we're just going to make sort of dotted lines connecting my blue and my orange dots here. Now this box is to help you to draw those asymptotes, and when you connect the corners of your box going through your center, that's going to help you when you are drawing the branches of your hyperbola. So this is sort of like a guide for us. Something else for you to remember is that your positive term is always going to be the vertices. So that's what was the blue. So the positive term, which was your first term, which was the x's, that's where you're going to use those vertices. Now, when you're finding your foci, remember that your foci is sort of going to always be inside your parabola. So the foci can never be like inside this box. So when you find your foci, you've got your equation, c squared equals a squared plus b squared. So you've got 9, and then you have 16, where you have 25, and c is plus or minus 5. Now when you do your foci again, you are going on that sort of major, the transverse axis, right? So we're going from that center, we're going 1, 2, 3, 4, 5. There's one focus, and 1, 2, 3, 4, 5. So you've got your 2 there. One of them is going to be at -7, 3. The other one will be at 3, 3. So here you've got some nice points there. Now you can take this information and then you can go ahead and graph. So you're going to use that vertices that you had, which was the blue, and then you're going to make sort of that curve along your dotted box and that X, which are your asymptotes there. So you got your branches of your hyperbola, again, both opening either to the right or to the left because we're opening in the horizontal direction. Okay, in question number 2, again, we are finding our center. Now your X is second, which means this X value or the X coordinate is going to be -4. Your Y is first, so that is going to be a +1. And you've got -4, 1 here for your center. The next thing you're going to do is you're going to see, all right, well, now I can figure out that this is a squared. And because this is on my Y, I'm going to be opening in the vertical direction. So we're going to either open up or down of our hyperbola. So for the vertices, I got a squared equals 25. So a is ±5. We are going to do 5 in both directions along your Y. So we're going up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. Your 2 vertices there. We've got -4 and 6, and you've got -4 and -4. We are going to still find our B value, so we can figure out that B is ±2, and that is along your X. So from your center, you're going 2 to the right and then 2 to the left. From here, you can draw your box. So use your points that you had. So my orange and my blue. I'm going to connect also going through my corners through that center. And that's going to, again, help me to do those branches of my hyperbola. Now, then to find our foci here, you've got your equation. So you've got, let's see, 25 and 4, which gets you 29. So C is ± the square root of 29. Now, this is about like 5.3. So when you count your foci, again, from the center, we're going to be counting about 5.3 units. So 1, 2, 3, 4, 5, and a little bit more in one direction and in the other direction. So just kind of do your best to go in between the 5 and 6 units counting from your center. Now to find the points for my foci, what I'm going to do is I'm going to say, well, I know from my center, they actually share the same X coordinate. However, the Y is going to change. So from that center where my Y coordinate was 1, I went up the square root of 29, and I also went down the square root of 29. So I only changed those Y coordinates. So that's why I took the 1 and I added and subtracted the square root of 29. Now what we can do is from our vertices, which is the blue, I'm going to make our curve, again, in the vertical direction. So I got to go up and down. And there you have your branches of your hyperbola. Okay, so in this question, we've got our foci information as well as our transverse axis information. Now, this is going to help us to get started here. The transverse axis, remember, is always the length of 2a. And because I actually know that the length is 8, I can make a little equation and I can get an a value of 4. Now what I'm going to do is I'm going to then use my foci and I'm going to say, oh, let me just figure out how this is going to look like. So if I were to imagine here, I got, let's say, -4, -2. So let's say my foci is there. And then I got 8, -2. So remember your foci along with your vertices. Again, remember on that sort of major axis there, that's going to be sort of telling us that this is going to be horizontal direction. So I'm going to have some type of hyperbola that kind of opens like this, right? Your foci is going to be inside that parabola, kind of inside that cup. So what we have then is we can say, all right, well, from that foci, let me find the center. So remember, I can take the values that I know. So -4 and 8, those are the ones that change. If I find the exact middle of that, you can get 4/2, which is 2. So the new x value is going to be 2, but that y value is still going to be the same as -2. So because you know this is going to be horizontal, and because you know your center, well, we can write down what formula we will use. And that would be the hyperbola formula for the horizontal direction. So we found our center and we know our A value. Now we have to find the B value. And how we can do that is we can say, all right, well, if I know my foci, so I'm going from the center to the foci, that's the C length. Now the difference from 2 to 8 is going to be 6. So I can use my formula here. And I can say 6 squared is equal to, A was 4. So I can say 36 and 16. I can subtract, and then I would get 20 for B squared. So now what you can do is you can say you've got x. So the x coordinate is going to be, that's the -2, because it's always a minus. You're going to have that squared divided by a squared, so that's 4 squared, which is 16. You're going to have a minus y. And then you've got your k value, which is a -2, that'll turn into a +2, and then square it. And then your b squared we found out was 20, and then that equals 1. If this video helped, give it a like and check out the rest of the conics playlist for circles, parabolas, and ellipses. Thanks for watching.